This section is on plurality with elimination. With this method, we're really looking for a majority candidate, and that's usually pretty hard to find when we have 3 or more candidates. Sometimes it happens, but a lot of the times it doesn't. And remember, a majority, we need more than half of the votes. Instant runoff voting, so that's what happens when somebody gets eliminated and their votes are going to go to someone else who's moving up in the ballot. So if we're looking for a majority candidate, if one does not exist, we're going to remove the candidate with the lowest amount of first place votes until we can get a majority candidate. And that's what the plurality with elimination method is called. We might have to do this a couple times within one problem. Okay, a little bit more detail. So round 1, we're going to count the first place votes for each candidate, just like you would in the plurality method. And if there's already someone that has the majority of the first place votes, then that candidate will be the winner. If there is no majority, then we need to eliminate the candidate with the fewest first place votes and move on. So after that's done, we're going to cross out that candidate. So the one that was eliminated, just put them out of the preference schedule, and we're going to recount all the first place votes. Now remember that after someone's eliminated, everyone below them needs to move up before we can actually do the recount. Okay, once that's done, look again to see if there's any majority, okay, because once you find a majority candidate, you can stop. If not, do the elimination again. Find the candidate with the least amount of first place votes, and then take them out. Round 3 and 4, and however many rounds it takes, just keep doing the same thing until you have a majority candidate. So check for that within each round. Okay, here's an example. Hopefully it'll clear some things up. Okay, using the plurality with elimination method, who won the election? Okay. Well, in this first round, first of all, let's check for a majority candidate. It looks like we have 6 plus 3 is 9, 14. So we have 22 total votes, which means we would need 12 total to be a majority. Okay. Now D has the most. It would be the plurality winner, but we're doing plurality with elimination. So D only has 9. Not enough for a majority just yet. So we're going to have to eliminate someone. And it looks like we'll be eliminating B because candidate B has no first place votes. So let's get rid of candidate B. Okay, and now everybody below B is going to move up, and I'm actually going to just rewrite all the columns out to make this a little more clear. So DAC, and the last column will remain the same because B was the last one in that column anyway. Okay, so now there's only 3 candidates to look at. For this second round, we need to, well, actually first we need to see if there's a majority candidate at this point. There's still 22 total votes. No one has more than 12, so we're going to have to keep moving. This time it looks like A is the one with the least amount of first place votes, with only 5 first place votes. So we're going to eliminate A from the schedule. Alright, and once again I'm just going to rewrite this out. So DC, DC, CD, CB, okay. Oops. This should have said D, and this needs to say D instead. Okay. And now we're just down to 2 candidates, and at this point there really should be a majority candidate with only 2. So in round 3, we have D with 9 first place votes, okay, but we have C with 13 first place votes. So C has majority, and 13 being more than 12, the minimum required to get the majority out of 22. So C wins. And that's interesting because if we were to just have done regular plurality method, D would have been the winner with 9 first place votes. But after doing these elimination rounds, C ended up coming out on top. And while doing these problems, what we'll find is that this does satisfy the majority criterion. So, for example, in this one, if someone has a majority of the first place votes, they should be the winner of the election. Well, using regular plurality, A would win this, and A is also the majority candidate. But let's work this one out using the elimination method just to check it. So, in round 1, we will eliminate D. Okay, in round 2, it looks like B is the one with the least amount of first place votes, so no more B. AC, CA, CA. Okay. And C's moved up in the ranks with 5 first place votes now that we're at round 3. But A is still the winner because it had the majority to begin with. So A with the 6 out of the 11 first place votes. So in our last round, A is still the winner. So what's the problem with this method? Okay, well here's another criterion. If candidate X is a winner of an election and in a re-election, the only changes in the ballots are changes that favor X and only X, then X should remain a winner of the election. Okay, so let's throw in an example to make a little more sense of this. Athens, Barcelona, and Calgary are competing to host the Summer Olympics. The final decision is made by a secret vote of the 29 members of the Executive Council of the IOC, and the winner will be chosen using the plurality with elimination method. Okay. A few days before the election, the results of a straw poll are leaked. Based on the results, Calgary is going to win. And we'll pull out some charts here. Okay, so if you look at the top chart, we have a straw poll, and if we were to use plurality with elimination for this, okay, so this is like an unofficial poll, then Calgary would win. And we can actually work that out real quick. This one won't take too long since there's only 3 candidates. So in round 1, if we were to eliminate someone, we would need to eliminate candidate B, who only has 8 first place votes. So eliminate B. Okay, and I'm going to rewrite everybody. So AC, CA, CA. Okay, and yeah, it's pretty clear here that so now C has 18 votes versus the 11 votes that A has. So definitely majority. So at that point, yeah. So there's a rumor that going around that C's probably going to win. So sometimes when you hear polls a little too early, you're thinking, man, I don't want to waste my vote on the person that's not going to win. So there's that insincere voting happening. And we have a lot of people that end up changing their votes. So all those who the last column who did who voted in the order ACB. Let's say that they combine their votes with these other 10 CAB voters. Okay, so these join up. And now there's 14 total CAB. Let's see what happens this time. So in round one, this time A gets eliminated first. A with only 7 first place votes. Okay, and let's rewrite it out. BC, BC, CB. Okay. Oh, and we can stop in the second round. Now B has 15 total votes, and C only has 14, and 15 would be the majority in that case. So B is actually our winner. And this doesn't really make a lot of sense if you think about it. I mean, in the first election, or at least in the first poll, when C won, if we combine this column with this column, it came out that C's going to have a lot more first place votes, but just after the elimination process and everything, it worked out that B won. So that's where the problem lies here. Okay, so that's a good example of a violation of the monotonicity criterion. And this can also sometimes violate the Condorcet criterion. So if we were to match everyone up head to head, the winner might not, or the Condorcet candidate might not actually be the winner.